Hi and welcome back to my YouTube channel. So in this video I'm going to be showing you how to carry out a structural equation modeling using categorical variables. So one of the biggest challenges researchers face is including categorical variables while carrying out structural equation modeling. In this quick video I'm going to be showing you how to do it. So basically I have a fictitious data set here wherein I have two categorical variables. One is gender, the other one is location. And I also have a scale which is exactly my scale. And then if you go to the variable view, you will see that the gender is divided into two categories, male and female, and then the location is divided into two categories as well, urban as well as rural. So my hypothesis is that those who are living in urban areas and those who belong to the male gender have a better life satisfaction, and that I'll be creating a structural equation modeling using this data, right? So the first step for me is to convert these categorical variables into separate individual variables as groups. This is done through dummy coding. So what I'll do is I'll go to transform. I'll go to recode into different variables. I'll just reset whatever was here. I'll go to gender and then I pull it in. I select it and then I type male. I give the name male. See, I am doing this in PSPP. You can also do the same thing in SPSS as well. So I'm doing this. I'll just go to old and new values. So under value, I'll be selecting 1. So 1 is considered male in my data set and 2 is female. So 1 will remain as 1. There's no change there. All other values, okay, will become 0. So basically I'm telling the computer to create a new variable where 1 will remain 1, the other will all remain 0. So this is a dummy variable for male gender. I'll click continue, click change, and then click OK. So if I go back to the data set, you'll see a new variable has been created called male, wherein all the male respondents have been coded as 1 and female have been coded as 0. So I'll do the same thing for the female respondents now. I'll go to transform, recode into different variables, click reset, select gender again, pull it in, and then I'll make sure that I am naming this as female because it's a new variable. I go to old and new values and I do the same thing. I make but here remember 2 is female, so value will be 2 and the new value will be 1. So 2 will become 1 and all other values will become 0. Click continue, click change, and then click OK. So I have created a new variable called female, and you can see those two are now separate variables. Now they're not the same variable. Now we'll move on to location. So in my data set, if you go to the variable view, you'll see that 1 is urban and 2 is rural. So I'll do the same thing here. Remember, 1 is urban, 2 is rural. So I go to transform, recode into different variables, click reset. I'll go to location, pull it in, select this. I'll call this urban, right? And then I click old and new values. So 1 will remain as 1. Okay, this is for urban. So all other values will become 0. So I'm creating another dummy variable here. Click continue, click change, click OK. Then we do the same thing for rural as well. So click on reset, pull location in again, select it, name it as rural, click change. I'm sorry, actually you could do it at the end. Value here, we'll add, you remember 2 was rural, so 2 will become 1 now, and then all other values will be 0. Click continue, click change, then click OK. So basically we successfully created 4 new dummy variables, and we'll be using this for our SEM analysis, right? So let's go ahead and do our SEM analysis now. Okay, so now we are back and we are using the structural equation modeling software, which is AMOS. Okay, so before I move to AMOS, make sure that the data set that you just created is saved. Okay, so I've saved it on my desktop. I call it sample data. So I just minimize this. The first thing I should do is make this bigger because it's too small. So I'll go to view and then interface properties. Under interface properties, I'll select landscape A4. That will make it at least slightly bigger. And just close this. So basically, I'll first create my latent variable, which is satisfaction with life. So I'll just click this. I can resize this, make sure that it's not so big. Yeah, I'll just keep it this short. And then I'll basically create my latent variable. So the variable has five individual items. So there's 1, 2, 3, 4, 5. I'll just rotate it so that it suits my model better. It's easier for me to present it. Then of course I have two independent variables. Remember, my hypothesis is that those who are male and those who live in urban areas have a better satisfaction with life. So this is one independent variable. I'll just duplicate this. This is the option to duplicate, and I'm just duplicating it here, right? So now I've basically set up my model. I need to fill in some details, but before that, let me import my data. So I'll click on select data file, click on file name, and then I'll select sample data, right? And then I click OK. So my data is loaded now. The next thing I need to do is I need to list the variables, right? So remember, the independent variable that I'm interested is in male, so I'll put there, and then the other variable I'm interested is in urban. So these are the two categorical variables that I'm interested in looking into. Then what I'm doing is I'm going to include the satisfaction with life in each of these sections. So I'll just put it in. Now since it looks too big, you can just delete the variable name so that it looks smaller. I mean, when you need to interpret it, you have to explain what SL1, SL2 means, but this makes the model look more presentable. So I'm just deleting this variable label. We still have the variable name. That should be sufficient for now. Now the next step is to draw the relationship. So here we go. We also have to name the unnamed variables. But before that, I also need to include an error term here. So including an error term for an endogenous variable is important. So I'm just including. So this is treated as an endogenous variable now because it's connected. So I have included the error term over here. The next thing we need to do is name the unnamed unobserved variables. So I just click this. So everything gets automatically renamed. Of course, you can rename this and call it SLS, which is satisfaction with life. For now, we'll just call it SLS. Satisfaction with life scale, actually. Now, the next thing we need to do is we need to go to analysis properties. So here, we will go to estimation, right? Estimate means and intercepts is something we are interested in looking into. Then with regard to output, right, I want standardized estimates. Okay, I need residual moments. Maybe I can use that. That's pretty much it, right? I don't want anything else apart from all this. So I don't want to do bootstrapping for now. We'll come to bootstrapping in another video maybe in the future. So we'll just close this for now, and then we click on calculate estimates. Now AMOS is giving me a warning. It's saying these two variables need to be correlated. Now this is just a suggestion. You don't have to do it, and it's actually not correlated, but it's giving me a suggestion. Why don't you try correlating this? I'm not going to do it because this is not correlated. So I'll just cancel. I'll just proceed with the analysis. I'm just going to ignore this. Right. I need to of course save this file. So I'll be saving it as maybe sample AMOS or sample SEM. That would be better. Then I click save. And yes, so I have the standardized estimates. These are the unstandardized estimates. The standardized estimates are here. The next thing I need to do is check the view text option. So under view text, I'll be able to see the estimates, right? Of course, the thing that I'm most interested in is of course the RMSEA value, and also other values like the CFI and so on. but the RMSE value is very easy to interpret. So I'm just going here. You can see that it's the model has a 0.036, which is below 0.05, which is considered to be an excellent fit. And P close is also not significant, which indicates that the model is an excellent fit. Right, the model is an excellent fit. So basically what we have done is we have taken the categorical variables and we have created a structural equation modeling. Right, so I hope you found this video useful. If you did, please do like and subscribe to my channel for more such videos. Thanks for watching, and bye for now.